Hey guys, this is JSer. How's everything going? In this video, I'm going to take a look at 958, check completeness of a binary tree. We just determine if a tree is complete, right? So for complete, there will be two conditions. First one, every level should be fully filled except the last one. Possibly, if there is, there must be something. If there's some layer not filled, it should be the last one. And for the last layer, all the nodes should be aligned to the left. Why? Well, as we see the description, we could know that we need to actually check the tree level by level, right? This reminds us this should be a BFS solution. There are two cases that the tree could be judged as not complete. First one, some layer is not filled except the last one. So all the layers except the last one there are some layer other than the last layer are not filled. So well, we could just check that layer by layer and compare the count to the node count to the expected. Like for the first layer, it expected to have one node. For the second, 2. For the third, it expected to have 4, but we have 3. But there's a problem that last one should be excluded. So we should actually compare the previous one, right? So for each layer, we actually will check previous layer to see if it is matches our node count or not. And next one is for each layer, for each level, the empty node should not be in the middle. So actually, for each layer, we traverse through from left to right. When we meet null empty node, we keep a flag to we set the flags to true that already we meet empty node. So next time when we meet not null node, like 6, we could check that flag to see if there is a empty node before the node, right? So we could use a flag to handle this. Let's begin, right? Our input, the tree will have at least one node, so it's not empty. We just put it in the queue. As we analyzed, there will be 2 flags. The first one is the priv level node count 0, right? Initialize to 0, and let priv level node count expected 0. Okay. Now for each layer, what we do, we'll first check the previous layer if it is valid or not. So if this is not equal to expected, return false, right? And then we need to update the expected, right? And update the previous node. So the previous node actually is the length of queue. And the previous node, it should be, if previous is 0, then it should be 1, or it should be double, right? And then for each node of the layer, we shifted them, and then push their child to the queue, right? So for this, I will usually push a null as an ending identifier, and then that head. And as we analyzed, we should keep a flag of is null met false. Now, if head left is not null and is null met, we should return false, right? Yeah. For the other case, we push the head left in the queue. If it is null, then is null met equals to true. we need to do the same for the right node. Right, if is null met, return false. Here push head right. For the other case is null met equals to true. Yeah, so after each layer, yeah, this is actually done. So there are two cases. One, previous layer is not fully filled. This check the case. Another case is that some null node in the middle will handle here. And then just return true, right? Cool. So that's it. Let's analyze the time and the spin. We got it. Wrong answer. 1, 2, 3, 4, 5, null 7. This is the case here. Wait a minute. If it's 0, 1, if not, we double. We push a null, and we shift head left, right, shift right. Is null met true. And the last we return true. What's wrong here? Q is the root. Proof node count should be Q length, right? We return what? Return true. Of course, it should be false. It means the case here is not handled right. Left, we shift. If there is left and already a null, return false. Yeah. Q push head left. If it is null, then it's null met set to true. And if head got there for 3, is already we set to is null met to true. And we got 7. We met the, we should return false. What? Is set to true? This is weird. This is weird. Let's check. What? There's only one. We shift, but we need to push. Uh-oh, my head doesn't work. Now, okay, and then Q.length, right? Console log Q.length 1 and 2. I know what happened. I got the wrong return. Shit. Yeah, we're accepted, and let's analyze the time and space. For time, each node actually will be traversed for 1, so it's linear time. N is the count of the nodes. Space, we use a queue, so for worst case, you will occupy the whole layer, maximum to half of the nodes, so, and divide half of the nodes. Yeah, it's still linear space. Okay, so that's all for this one. Hope you help. See you next time. Bye bye.